Good morning. Welcome to our first video. I'm sorry that the image is not good. I can see it's grainy and the light is weird. That's because this camera is really not made to be recording this type of videos. So I've ordered another camera. It's going to arrive soon, so that's going to be fixed. Also, if you notice me spinning or sinking down, that's because the camera is attached to a stool with that type of clay that the kids play with, so it's kind of moving around. Again, this will be fixed. I just wanted to start the lessons as soon as possible. So today we're going to talk about the nucleus of the atom. So as you remember, we did some of this, and this is more like a reminder, and it's made to review it and put everything in one place where you can find it. So as we know, the atom is made of nucleus and an electrons moving around it. We can forget about the electrons for now. We're just going to talk about the nucleus. So let's just represent the nucleus. So the nucleus is made of basically this. It's made of protons, and so protons are positive and they're usually marked as P+, and neutrons are neutral and they're usually marked as N0. So any nucleus can contain a certain number of protons and neutrons depending on which element that is. The electrons are moving around, and we're going to learn about how they're moving around the nucleus. They're not moving in an ellipse or a circle, but that we're going to forget that for now. I only want you to remember one thing, is that most of the mass of the atom depends on protons and neutrons. So proton is about equal in mass to neutron, not exactly but almost equal, and they're both much larger in mass than an electron. It's about one neutron or one proton equals around 1,800 electrons in mass. Around, again, that's not really equal. So most of the mass of the whole atom is in the nucleus. Now, if we try to remember what we did before when we learned about the periodic table, is that there are two numbers in the periodic table which are considered to be most important. Let's take an example of lithium right now. So lithium has two numbers, a smaller number and a bigger number. The smaller number is called an atomic number, and a bigger number is called a mass number. So usually in chemistry, when we note this, we note it in this way. So we write lithium here, and then we write the bigger number here, 7, and the smaller number here, 3. So this is how we denote lithium. Now, what is the smaller number? So the smaller number is it's called an atomic number, and it equals to the number of protons in the nucleus of that element. The bigger number is called a mass number. And this one can actually mean a lot of things, but for now, let's just say that's the number of protons plus the number of neutrons. So see, again, 3 is number of protons and 7 is number of protons plus neutrons. Protons and neutrons together are sometimes called nucleons. Nucleons. Because they're in the nucleus, so combined they're called nucleons. So by observing these two numbers right here, we can determine that how many protons, neutrons, and electrons lithium has, and we can even draw it. So number of protons in lithium is 3, right? Number of neutrons is 7, because 7 is protons plus neutrons, minus 3, and that equals 4. So if we would want to draw this, it's simple. We'll have 7 nucleons, and 3 of these would be positive, would be protons. So it's very easy by using these two numbers to have a picture in your head of how the nucleus of this element actually looks like. Now, there are other meanings that you will see, and there are other ways to write this. For example, when they write lithium, they might also write like this, Li and then 7. In this case, this 7 is obviously the mass number. So you'll notice other elements like hydrogen 1, that means this is hydrogen and its mass number is 1. And then you might notice others like, I don't know, let's take a random one. Sodium 23. So if you see something written in this way, know that this number after the dash, after the element and the dash, that's a mass number. It's not the atomic number. You'll see later why. But let's turn to another thing right now, and that's this. See, mass number, the name itself says it has something to do with the mass of the element. Again, I repeat, remember, most of the mass, almost all of the mass of an atom is in the nucleus. So the mass number, since it represents the number of nucleons, so protons and neutrons together, most of it also represents the mass of that atom. So 7, or the mass number, means, again, number of protons plus neutrons. We know that. But also 7, sometimes you have a unit. 7 also means that one atom of lithium has a mass of 7 AMU. This AMU means atomic mass units. Why is it like this? So one proton or one neutron, since they have equal mass, their weight is 1 atomic mass unit. Why is it like this? Because protons and neutrons and even atoms are too light to be for their weight to be expressed in grams. So their weight is expressed in atomic mass units. So the mass number of an element means that the nucleus, which is to say the mass of the nucleus, which is actually the mass of the whole element because the electrons weigh nothing. So if I look at here, I say, okay, beryllium has a mass number of 9.01. That means the mass of one atom of beryllium is 9.01 atomic mass units, or AMU. Calcium is 40.08. The mass number is 40.08. Means that one atom of calcium has a mass of 40.08 atomic mass units. There is a third meaning to this, which is 7 grams per mole. We will discuss this one in more detail later, but obviously we see here grams, this is G. So 7 grams, one atom obviously cannot weigh 7 grams, but 1 mole can. Mole is a unit that means trillions and trillions of atoms. And it has a specific meaning in chemistry. For now, I just want you to know that if you see sometimes somebody expressing atomic mass or the mass number as 7 AMU or 7 gram per mole, you should know that this is what it means. Okay, let's see what to do next.